we're just sending out a study now where we looked at kind of methylation of RNA. But an amazing thing the National Institute of Aging has done is it's assembled these databases that have RNA and protein and DNA from thousands of people. And that becomes important because, Randy, I'm sure you would agree, you're not like me. And although, we look somewhat similar, we also have differences. And when you go to actually people with more differences, it becomes more extreme and things respond differently. So you really need to look at a large number of people. Like if you listen to the news, you've heard that there's this somewhat controversial antibody treatment for Alzheimer's disease. And I'm not going to defend it or anything, but it has about a 36% efficacy. And that's debatable whether that's helpful. But if you actually go and dig in the data, it's interesting what you see. It turns out it's much more effective in men than in women. And the efficacy in men is like 40%. The efficacy in women, lower, like, less than 20%. So according to the stats, it's actually not going to be super beneficial for women, better for men. That emphasizes something that's so true, which is when you study the disease, you can't just study, like if you develop a therapy for just one person, guess what? You'll help that person, but that person that doesn't look like them, you might not help. If you compare the biggest risk factor for Alzheimer's is something called ApoE4. Us white guys, if we have 2 of those genes, our risk of Alzheimer's goes up 16-fold. If we're Asian and we have 2 of those genes, our risk goes up 35-fold. If we are African American and we have those genes, our risk goes up only 2-fold. However, it turns out that our general risk of dementia is twice that of you and me, if you're African American. So the disease must be different. We have to figure out how to treat it. We have to look at all of that.